Hi, everyone. Welcome to today's webinar, Configure Your AKS Cluster with Confidence. My name is Kendall Roden, and I'm joined by my teammate, Ray Ko. We're both technical specialists from the Cloud Native Global Black Belt team at Microsoft. And we'll do another quick intro of who we are, but first, let's kick it off with an agenda. So what we're going to be covering today really is doing a quick welcome and introduction, talking through a cluster setup for kind of, I wouldn't even say it necessarily a full baseline cluster, but I would say the baseline that's opinionated from Ray and I's perspective, things that you really should consider day one, maybe even day two. And then we'll walk through some of those design decisions and talk about, why did we choose the things that we did? Why did we think that those were really important to call out, and what some of our recommendations are around this. And then we'll open it up for what would have been Q&A. We did do a live session, so if you were able to join that, great. We'll keep that out for now, and then we'll just do a quick review and next steps. I do want to call out that we had Q&A that we did get and capture from the live session, and we'll post that on the same GitHub repo where you can find all of the materials, including the slide deck. So if you want to refer back to that, that would be a great way to do that kind of in a synchronous way. So a little bit about me. As I mentioned, my name is Kendall. I'm based in Dallas, Texas. I've been at Microsoft for around 5 years now. As I mentioned, technical specialist on the Cloud Native Global Black Belt team. I started as a co-host on the Azure podcast probably a year into Microsoft. And so that's a great way to learn about Azure if you're interested in just getting a better understanding of the variety of services and the new updates that we re-release. So I've really enjoyed doing that. Pretty active on Twitter, so if you're interested in connecting with me, definitely find me there at Kendall Roden. And then obviously pretty passionate about Kubernetes. Have had the opportunity to serve as a release team shadow for a few releases on the Upstream project, which has been a really cool eye-opening experience in terms of how a large open source project is run. So that's a little bit about me, but I'll pass it over to Ray to introduce himself.
Yeah, thanks, Kendall. Hi, I'm Rico. I like following Kendall on these calls because my intro is very short. I'm on the exact same team, same role as Kendall. I'm not as involved in Kubernetes ecosystem as she is, but you can find me on Twitter the same way, Rico, and GitHub as well, same handle. Good to meet you all.
And Ray's pretty awesome and also lives in Canada, which is pretty neat. Just a quick call out there. We have half of our team is actually based in Canada, which is pretty cool. Yeah. So just want to cover some expectations for the session itself. So what this session is and what it isn't, especially for those of you who are tuning in today. So we're not going to cover 100 level Kubernetes. It is something that we're assuming you have a little bit of Kubernetes knowledge, a little bit of AKS experience. There are a lot of great resources that we'll link after this if you're interested in digging more into some of the fundamentals. And then it's also not going to be a fully comprehensive 300 level deep dive into every single configuration for AKS, right? So we chose what we feel like are some configurations we want to highlight, some features we think are really relevant, especially if you're at that 200 level, kind of trying to iterate and think about how you want to take your AKS configuration to the next level. And some of this is based on our opinions and experiences. So biggest thing here to caveat is that, Ray and myself are not the ultimate sayers of what you should or shouldn't do, right? But we do have opinions, we do have some experience. So, please take that as you will and decide what maybe fits for your organization and maybe where you disagree or would like to take a different approach. So I'll let Ray kind of talk a little bit through the process. We both agreed that this was a really cool slide and we felt very passionately about what it was trying to convey. So I'll let Ray give his thoughts on what the process looks like and kind of what our web series is trying to accomplish in aiding in this process.
Yeah, thanks, Neil. So our webinar series is really taking at that large arrow perspective, right? Like we're not trying to teach you the basics of what Azure is or what Kubernetes is or what even AKS at a basic managed service level actually is trying to achieve for you. So we're not jumpstart that. Those two levels, learn and align, go do that as homework. We're presuming that you're coming in at this large arrow perspective where you've already played with it, you've tinkered with it. And what we're trying to really drill into this series and taking this iterative approach, the big red or orange circle there on the bottom, is that each webinar is going to build upon the previous session's knowledge, right? And that going forward, even as you build out your Kubernetes cluster or you work with AKS, there are going to be new features that come out. There are going to be things where you have to upgrade the cluster, and there's no choice but to redeploy the cluster. In fact, there are some best practices where you probably should be redeploying the cluster altogether when you're rolling out a new version, as an example, of the cluster itself, not necessarily your app. So again, the main process of this is to build on the idea of principles of what you're trying to actually manage and control yourself, what the platform provides for you, what are the best practices, which will change tomorrow, next month, next quarter, and then be confident enough to actually iterate on this as a process for essentially the rest of your life, unfortunately.
Yeah, I totally agree with this. And I think we do see some customers who, once they make a decision to go Kubernetes, they kind of want to do everything, right? Let's throw a service mesh on top. Let's get full functionality of everything the open source community provides. And I think the goal here is how do we get something that's kind of operational, can meet our workload needs. And then as our needs grow, we can start evolving and adding on additional flavors and features as our demands change. So so quick I guess just reiteration of what we're covering today, configuring your cluster with confidence. We do have a couple of upcoming sessions. This is going to be relevant if you're watching the video, within the next week, probably not as relevant afterward, but just keep in mind, this is a 3-part series, and we'll make sure that the link to the remaining 2 sessions is uploaded alongside the video. So I want to talk a little bit about our baseline cluster today. So the approach that we're taking, as I mentioned, is here's what we're going to deploy. Here's our cluster configuration, and then kind of breaking that down, right? Why did we make those decisions? And so we did provide some cluster configuration for you to actually get up and running yourself. And this will be posted on GitHub and available, for as long as we keep that repo up, which is going to be, essentially forever. I don't know. So no matter when you're watching this, I think this will still be, pertinent to you. So we have 2 options essentially for provisioning that we included in the GitHub repo. One of them is Azure Resource Manager, the other Terraform. I just wanted to do kind of a quick call out as to the fact that yes, Azure Resource Manager templates are typically the most native Azure way to provision resources within, the Azure cloud itself. But we see a lot of customers that love using Terraform. And one of the major differences is Terraform is obviously an abstraction above the cloud provider or the host in which you're deploying to. And so you can kind of get that single configuration language across cloud providers, across on-premises deployments. And so if you're using Terraform and that works great and that's where your skill set is, we want to continue to encourage you to do that. We don't see any major mitigating factors for why Terraform can't be a great solution. I will say, one of the nuances is typically ARM is going to have the most recent features included earlier on, right? So an ARM template will support a new add-on per se, or a new add-on preview before something like Terraform would integrate that into their modules. So that's just something to, to keep in mind. Both of them have a process for getting an idea of what is actually going to be deployed to the subscription before you actually have to apply it. And so a lot of the same features and functionality. Another really quick call out is just if you're new to the concept of Bicep, we have created a new essentially like ARM resource manager template provisioning language. So if you want to create an ARM template, but you want to use a more, I would say, codified way to do that, or a code first approach, Bicep is a really good way to do that. It looks very similar to C#, kind of declaring variables, having things where you can iterate through loops in a way that's going to look really familiar if you're within the Microsoft or Windows ecosystem. And so really cool call out. So we have a Bicep template in there, and then we have a Terraform template. So this is what the structure of the GitHub repo actually looks like. Essentially, each webinar will have a named directory, and within that directory, we'll have various folders for, each of the templates and any other relevant documentation, including the slide deck, which will be posted there after today's recording. And then I want to call out too, we also will have a Q&A section where we post questions and answers that are relevant to the topics that we're covering. So within our baseline cluster, and I'll actually walk you through some of that configuration in just a moment, but we basically made, like I said, some opinionated decisions around what we wanted to include. And so when it comes to the compute and infrastructure bit, we chose to use managed identity versus the traditional service principal approach. We chose to enable the uptime SLA, and we chose to use both system and user node pools. So the concept of node pools may be new or unfamiliar. We'll make sure to kind of cover that at a high level, but we'll also talk about what the value is of using both system and user node pools. And then we'll talk a little bit about process. So what are some of the things process oriented that you want to get right or start establishing a plan for as you're moving toward configuring that baseline cluster. One of them is, how am I going to securely access the container images that are going to be deployed on top of my cluster? So how do we integrate some kind of registry? In this case, we'll talk about Azure Container Registry. How do I create a plan for upgrading my cluster, right? Once I provision my cluster, that's great, but how am I going to take it, to the next version, or how am I going to make sure that the node OS gets properly updated? And then last but not least, we'll talk about Azure AD and RBAC, a process that helps us to do authentication and authorization. We'll talk about networking, making that decision, right? KubeNet or Azure CNI. We felt like using Azure CNI was the recommended approach that we went with. KubeNet can be, appropriate in some cases, but we'll talk through kind of what you have to think about when you make that decision. And then we went ahead and enabled network policy, specifically using Calico, and we'll also talk about that. And then last but not least, we'll cover a little bit about observability and a quick win with enabling Azure Container Insights. So now that we've kind of covered through a little bit of that, I am going to switch over to VS Code and show you a quick little walkthrough of some of our templates that I mentioned in the previous few slides. So you see here we have both Bicep and we have Terraform. Feel free to use both or either in order to provision the setup that we just walked through. Basically, if you're new to Terraform, if you're new to Bicep, I'll go ahead and show Bicep just because it is pretty interesting if you've maybe never used it before. But both of these scripts are going to have a parameters.json file or some kind of variables file within Terraform in order to be able to set some of those initial variables, things like the Kubernetes version. And also when it comes to doing that Azure AD integration, we actually went ahead and created an admin group within our Azure AD tenant in order to basically assign that cluster admin privileges, which we'll talk about as we move through the deck. But within this main Bicep template, we essentially see that we're going through and creating our AKS cluster with the expected parameters. So we're passing in some parameters that we've already defined for AKS cluster, which we can see here. You can see that we are passing in the Kubernetes version at the lower level main Bicep template. We're using system assigned managed identity for provisioning, as mentioned. We're using Azure CNI for network. We're using Calico for Azure policy, or at least for Azure network policy. And then you can see we're passing in some other information regarding Kubernetes networking. We have enabled that paid SLA. We're using a standard load balancer. And then you can see we have enabled RBAC and AAD. And then those admin group objects I already mentioned have been established in that parameters.json file and will get passed in when we're actually doing the provisioning of the cluster. And then we're setting some other important variables here, which are referenced in that main Bicep template, things like the default node pool, right? And so that default node pool going to be really specifically for our critical add-ons that help Kubernetes or AKS system pods to run. And then we'll create a user node pool, which is really focused on our workload. And so these are just some things for you to continue to look through in order to get a good idea of what we have going on here. You can also see we've enabled log analytics workspace. We pass in that workspace ID in order to get that monitoring and logging that we mentioned before. And so lots going on here, but pretty similar if you've used Terraform, if you've used resource manager templates, it won't look too different. You can see here we're just setting up some of the important things when it comes to our VNet and subnet. And then obviously you can go through this main template and kind of see the references. You can see we're creating a container registry, and we're also creating some permissions in order to be able to create an ACR role that will give the cluster permission to talk to that Azure Container Registry. So feel free to play around with these. And remember, anything that we talk about today, creating another user node pool, changing the number of pods that can run within a node pool, all of that can be done, via this configuration and then applied in an incremental way. So let's switch back over to the presentation, if that sounds good to everyone, and we'll keep going. So let's see. Perfect. So I've showed you a quick overview of some of those scripts. We've talked a little bit about baseline, what we're creating. So now let's talk a little bit about the decisions that we made, right? So within that compute and infrastructure bucket, as mentioned, we did managed identity, we used uptime SLA, and we talked through system and user node pools. So let's take a quick look at why we made those decisions, right? Because sometimes you'll hear, okay, use managed identity. Well, why managed identity? What's wrong with the traditional approach? Why not use a service principal? Or maybe what do we get with one that we don't get with another? So let's just go over a quick understanding of how we approached this this decision, right? Service principal or managed identity. So I want to be very clear about, why are these even relevant? So when we create a Kubernetes cluster in Azure, AKS, we basically require some kind of identity that will allow the cluster to create additional resources like load balancers, managed disks, potentially an Azure Container Registry connection, things like this. So the service principal or managed identity is needed in order to dynamically create the backend resources that we need in Azure in order to make the Kubernetes cluster run. Think things like even VM scale sets. So why do we need these? Well, if you think about it, right, if we have an application or a service that we want to give access to create Azure resources, our traditional approach, if we think Azure Active Directory, is we create user identities, right, to manage what people in our organization can do within a subscription or on a resource group. But when we think about these apps and services, how do we give them identities? Well, maybe our natural thought would be, hey, we can create a fake user, right? I can create, app one user identity, and then I can assign that and give it certain permissions. But basically what a service principal and managed identity allow you to do is offload that need, right? Let's not create, fake John Doe or John Smith user identity and just assign it arbitrarily to our service to give it access. Instead, we can use things like service principals. And these service principals can obviously be restricted by assigning certain Azure roles that allow them to do certain things on a subset of resources. So what's the difference between service principal and managed identity when it comes to AKS? Well, if we use a service principal, or if we choose to use a service principal in the AKS cluster creation, you can bring one, which means you create it in Azure AD. You go through that entire process of creating the client app, registration, things like that. Or you can actually have it auto create during the cluster creation process. And like I mentioned, requires registering an app with an AAD, and you typically are going to do that via a manual process. It's valid for a year. You can rotate it ad hoc, but that's something that you would have to do, right? And in order to have access, you have to continue to make sure that you have those credentials that you initially created when the cluster was created. And then when you delete your AKS cluster, go in and remove the resource group or maybe roll back the ARM deployment, you actually don't get that service principal automatically cleaned up for you. So you're going to have to go in and manually remove that from Azure Active Directory. So what does managed identity provide on top of that? Well, essentially, it's just a management wrapper on top of a service principal. So from a functionality perspective, they are quite literally the same thing. A managed identity is just a service principal that Azure is actually managing for you. So it's typically auto-created when you do create your cluster, and then it'll be rotated automatically on your behalf every 46 days. Within managed identity, there are the concept of both system and user assigned. System assigned, think of it really being a one-to-one relationship with a specific Azure resource. So, I provision an app service. With that, I provision a system assigned managed identity. When I kill that app service, the managed identity will be killed alongside of it. They share the same life cycle, and you can give it certain permissions to access other resources. Now, a user assigned is a little bit different. I'm going to go in Kendall, and I'm going to create an identity within Azure, a managed identity. And I can then take that managed identity and actually apply it across multiple resources that might share the same needs, right? So maybe a good example of this is actually pod identity in Kubernetes. So I might have pods that all need the same level of access to something like a key vault. I can create one managed identity that has permission to access the key vault at the proper scoped level, and then I can assign multiple pods the same identity. So keep that in mind. That's kind of the difference there. System assigned one-to-one, user assigned multiple services can share the same. So baseline, I would say use managed identity wherever you can. The biggest reason why is because somebody has to go provision that service principal, and whoever does that is going to have access to the client ID in secret. And on top of that, so is your consumer. So because of that, there's potential exploitability, if that's the right word. There's potential ability for something to be exploited. Sorry, I get ahead of myself. I get excited. So big key here is let's just abstract away anybody knowing what those parameters are, right? We don't need anybody to see this information. Instead, let's just create a managed identity, have Azure be a secure store for that, and have it manage our service principal so we don't have to do it ourselves. And like I said, this couples really well with the concept of pod managed identity. This is in preview on AKS, but pod identity as an open source project can still be leveraged outside of that. So I was going to say any questions, but I think Ray and Matt, I think they've got it. So we'll keep moving. So why did we choose uptime SLA, especially for kind of this baseline cluster? Is that really necessary? Well, the big thing is, back in 2017, when we went with a preview of AKS, we were actually the first cloud provider that offered a free Kubernetes managed service. So what does that mean? It means you're really only paying for the compute. You're not paying for the actual management of the Kubernetes components. And so when we provided it as a free service, we could not back it with something financial, right? Instead, it came with a service level objective instead of a service level agreement. And so we said, hey, we have an SLO of 99.5, but if we don't meet that, you're not actually paying anything. So there's not necessarily a comparable, mitigating action that we can take on your behalf. And so recently we came out with the uptime SLA. So not only do we get higher availability, so 99.95, and I believe it's 9999, so 4 nines if you're using availability zones. It's now financially backed. So we get better availability, we get the financial backing, and then we can basically say it's a compliance win, right? So a lot of large organizations, they need to be able to have something with an SLA. It's based on the number of clusters, not the cluster size. And I will say, in general, because of some of the changes we made to the backend infrastructure, if you do enable that uptime SLA, you're guaranteed to be on that latest and greatest in the Azure, data center. So I think that's always a really good win here. So why not use it? It's low cost. It gives you that security, that peace of mind is worth probably 10 cents an hour. So I think that it's a recommendation we have. But hey, maybe not for dev test. Maybe we're, maybe really just focus on production. And then last but not least, in the decision-making process from the cluster configuration perspective, we went with using multiple node pools. So let's just talk about kind of the what of node pools, and then we'll talk about the why. Not only the why of node pools in general, but why system and user node pools. So within a single cluster, you can have up to 10 node pools, and within each of those node pools, you can run up to 100 nodes. So that gives you about 1,000 nodes in a cluster possibility. So within a node pool, which just think of a node pool as a grouping of underlying compute, right? A grouping of the virtual machines that are actually running underneath your cluster in order to host your workload. And so within a node pool, you can make very specific decisions about the compute that's running in that particular group. And so the group or node pool within it, you can have a single SKU. So what that means is a node pool will have one SKU. You could do a DSV2 for one of the node pools, and then you could choose to do, a DS, I think it's like V4, right? And so I make decisions about the SKU at the node pool level. And then within the node pool concept, as I mentioned, right, there's user and system node pools. So think of a system node pool as being the node pool that's going to run all of your critical Kubernetes components, especially within AKS, things like core DNS, tunnel front, things that are critical for network communication, within your cluster, DNS resolution, those kind of things. So whenever you create a cluster, you always have to have at least one system node pool. And that's because obviously, if you have nowhere that you can run your system pods, then you have an issue, right? You can't run your workload. And then think about the user node pool really being where your user workloads run, where your particular application deployment goes. And you can use advanced scheduling options in order to kind of segregate these two things and then have more granular control over the amount of compute within your cluster and the type of compute that's available. So the minimum and maximum number of pods that run within each of these node pools can be different, right? You can make really specific configuration choices about each of the individual node pools. So why are we using this? Well, right, optimizing compute needs. Maybe I want to run a few of my applications on GPU enabled nodes and others don't need that, right? Well, I would really like to segregate that GPU node pool, give it the SKU number so that I'm not running an entire cluster with GPU enablement when I really only need that for a specific workload. We can also get some update efficiency in the sense that we can do things like rolling updates for each of the node pools. We can do blue-green node pool deployments. And so it gives us some flexibility in how we choose to upgrade and even potentially, bring in new workloads to our cluster. So that's where the room for growth and flexibility comes in, right? As my workload evolves and changes, I can add new node pools that can meet specific needs based on my workload needs. And I think a lot of this that we're not covering really goes into cluster, multi-cluster kind of, I'm going to have a cluster per workload, or I'm going to more logically isolate a single cluster, which we see a lot, right, through the use of namespaces and other things. This is a further level of segregation, right, because you're really segregating your workload even at the node pool level, which is, a valuable thing to be able to do. So think about things like being able to have these dedicated nodes for even a set of users. So maybe I want to have a single, subset of a development team that has its own node pool within the cluster, right? And then I can configure certain needs there. So what are some of the ramifications, or what are some of the other things I need to be aware of whenever I actually use node pools? So one of them is going to be the Kubernetes scheduler behavior, right? If I want to take that segregation and really make it possible, I need to use things like labels, taints, tolerations, other concepts in order to really be able to mitigate when and where my pods are being scheduled. And so for a quick example, let's say that we have a node pool and we decide that we're going to taint that node pool and say that it can only run a specific subset of application workload on my cluster. When I deploy that application workload and I deploy, I have a deployment that has pods, I want to make sure that that deployment has a toleration for the taint on the node. And so basically all that says is, if a deployment comes in that doesn't tolerate my taint, then it can't be run on me. And so that's really allowing you to use that configuration and that Kubernetes YAML in order to help your pods be scheduled in the way that you want them, where you want them. And so I recommend definitely digging deeper into the concept of node affinity in general, taints and tolerations. There's a lot of great documentation out there to help you understand what can meet your need. So some additional considerations are things like cross-workload clusters. So if you want to use Windows containers, node pool is the way to go, because then you can create a Windows-specific node pool. So that's a really good example of showing you, hey, you know what? I only can run these Windows pods on a Windows node. I'm obviously going to taint the node, and I'm also going to make sure that I tolerate that taint on all of my Windows deployments. And you also want to think about, hey, maybe don't run system pods on a Windows node pool, because that's not going to work out very well, right? And so these are things that you have to keep in mind. If you do want to use node pools, you do have to use the standard SKU load balancer. You have to enable virtual machine scale sets. Now, what's really cool is node pools cannot span virtual networks, but they can span subnets. So within a single virtual network, you could actually assign each of these node pools its own subnet. So if you want further isolation, even from a networking perspective, this is a great way to go. And then you can actually set a taint not just at the specific, VM or compute level, but at the node pool level. So you could taint an entire node pool. And then obviously what you can do is use something like the Kubernetes admission controller to annotate pods that you want to be admitted and have a toleration for that taint. So there's ways that you can automate this process in order to make this the most efficient possible setup. And then one thing I will say that's interesting and just a nuance, especially since we did provide an ARM template or a bicep template for you to provision. Once you create the initial node pool profile, so let's say you go in and create an AKS cluster and didn't use node pools, it will by default create a system node pool for you. And that system node pool will also allow your user workload to run on top of it, right? So all of your pods are going to be running in that single node pool. But it's important to recognize, if you do create other node pools in that initial configuration, and then you want to make changes to the initial configuration, you can't do that in your initial ARM template. So you actually have to create a separate ARM template to be able to make modifications to your initial node pool deployment. So that's just like a pretty weird nuance, but something that you should be aware of if you take this approach. So now that we've talked through a lot of this, I'm going to pass it over to Ray. You don't have to listen to me anymore, which is a quick win for you. And he'll talk through a little bit about the upgrade strategy, especially when you're using something like node pools. And then we'll continue from there. So Ray, I'll pass it over to you.
Okay, thanks, Kendall. This is interesting part, the handoff to the right screen. Let me get this going. Okay, I think it's sharing the right window I have. You see my PowerPoint?
Yes, we can. We see it from the beginning, but yeah, we can see it.
Excellent. Okay, so skip through. All right, here we are. We're on the right one now. So I'm just gonna blow up this slide. So things to consider when you're going to basically upgrade your node pool. There are a number of different strategies you can take. In this particular slide, I want to break it down into the three sort of high-level ideas that you need to consider when upgrading a cluster. The first one is the shotgun approach, cluster upgrade. We just want to have Azure manage that for us and upgrade everything in one shot. So it'll upgrade our control plane, use Kubernetes version, it'll upgrade our node pools, or nodes within our cluster one at a time. So it'll be doing a rolling out. We send one command, and Azure will manage that whole rollout process on our behalf. Now, that's great for small clusters. That's great for probably dev and test environments. Probably not so great in a production sense. And the reason being is because, first of all, a rolling update, taking one node down at a time, takes some time, especially if we've deployed the full 1,000 node cluster. That could be days or potentially weeks, depending on how long that process takes. It's on average about, let's call it 10 minutes node. So if you do the math, that's going to take some time. So what we can probably do instead is take a more step-by-step approach. And this is going to be a little bit more manual, but we do provide you the command lines for you to figure out what that orchestration will look like. The first one being, of course, that you can target a control plane only upgrade. So we want to go from like Kubernetes 118 to 119. We can target an upgrade of the control plane first, and then start thinking about, okay, we're going to now roll out the individual nodes within a given pool, or we're going to target specific node pools. We have that control at that point. The control plane upgrade also is relatively quick, right? So you might see a small like 5-minute window or 10-minute window downtime the control plane. That's okay. That just means you can't schedule new or issue new commands to the control plane. It's unavailable, but your services within the cluster are still running. So it doesn't affect, HTTP routing to a microservice or your, larger ecosystem apps. If they're running, they're still good, no problem. Now, going to the node pool upgrade perspective, there are two different options you have. You can just target an upgrade of the Kubernetes version itself, do an in-place upgrade of the actual node, or you can swap out the image completely. Which strategy you want to take, it's up to you. The command line does provide that for you. Now, thinking about your node pool upgrades, you could also do a shotgun upgrade all node pools rolling update from that perspective, which is, good, again, if it's a small cluster or one that you don't need as much micromanagement of that managed rollout, so to speak. What you probably want to do instead is I want to target a specific node pool at a time. I only want one node pool or one VM type down at any given point. And I also want to manage the number of nodes that go down at any given point, or I want to target particular nodes. And so what we can do in this sense is, I can target a given node pool. Let's call it node pool 1, node pool 2, or node pool 10, whichever one I want. And then within that given node pool, I can actually say things like I want a maximum number of nodes to be updating at any given time. So instead of doing the rolling update of one node at a time, I can say something like max surge 2 or 3 or 10 given in my pool. So that can move along a little faster. So given that those strategies in place, you will have to, especially in a production environment, figure out what that coordination looks like. Check for, is the control plane back up? Did the node pool actually provision accordingly? Is it in a ready state? Are all the apps that I expected to be on those node pools, are they there? So those are things that you have to take care of yourself, and the managed service of AKS does not provide for you out of the box. Considerations when you're doing upgrades. So there are major minor releases. From an Azure perspective, we only support N-2. So once we go with Kubernetes 120, we'll only support up to 118 and the sub flavors of 118 within there. So 117 now becomes on a unsupported path. That's not to say your cluster gets removed. It's just that when you sign up for an Azure support ticket, best effort, but really 118 you should be getting up to at least 118 or potentially getting it up as close to 120 as you can. Security patches and upgrades of the actual nodes themselves. So let's say it's a 0-day or some kind of CVE that must be mitigated immediately. From an Azure perspective, from an AKS perspective, we'll take care of that and update that for you transparently on your behalf. So you don't have to worry about those. But all other upgrades, major minor version of Kubernetes, the underlying OS, those are explicit. You must opt in to issuing those commands and do that on your behalf for your clusters. There are customers, especially if they want like dev test environments to be automatically run right away. They don't want to issue the command themselves. There is a preview cluster auto upgrade feature that's coming out. Again, it's in preview, but what that allows you to do is choose a specific channel. So there's like a dev channel, there's like a stable channel that will automatically upgrade your cluster once it's available for you. You can opt into a upgrade window. So like, let's say you prefer 3 in the morning because that's the lowest usage, and then that channel will only upgrade given that time and window of the day, right? So that is coming out. So some additional points in here about this. So I mentioned max surge. So you can set a percentage of your nodes that can be down at any given time. So the default is 1, right? So that can take a long time. I want to speed it up a little bit, and I'm okay with a little bit more disruption in that sense. Maybe I want to bump it up to like 10% of my cluster, depending on the size of it is, 20, 50, or if you're really excited, 80%. Let's do this as quickly as possible. Or you can set it to a max integer value. So only 2 nodes, 3 nodes, something like that. If you are issuing things like pod disruption budgets in your environment, this basically says I am only going to allow a certain number of pods to be down at any given point, right? And in that sense, those could disrupt your upgrade of your cluster because it's not going to allow, let's say, you only have 5 instances of a pod being deployed. They're all on one single node. If it goes down, that might block, for some reason, the actual upgrade process itself. So be aware of that. And also set that value so that when you're doing the upgrade, the cluster itself, Kubernetes itself, can help you figure out how to coordinate that on your path. So it's not just nodes, it's your actual applications themselves. Upgrading the control plane only, probably the best path in terms of doing it in production. The other thing to speed up your process, instead of doing the in-place upgrades, what you might want to get into the practice of doing is blue-green node pool deployments instead. Because every time I create a new node pool, it automatically gets the latest OS image itself. And you can actually target a specific Kubernetes version when I deploy at the node pool deployment time. So what I can do is I'll add a whole new node pool myself manually. I'll cordon and drain an old node pool and let that kind of Kubernetes figure out to reschedule either onto the new node pool or just kind of scattered across the cluster, depending on what your labels, tolerations, taints, etc. have been set to. This process is a little bit faster than actually doing an in-place upgrade because I'm no longer having to take one node down, bring a new one up, and so on. I'm just going to do a wholesale kind of migration of all my workloads across my cluster, and then I can move on accordingly. This process is not really available via command line. Again, you have to kind of coordinate that, but we do provide tooling like the Azure AKS node pool add command line feature, which allow you to kind of manage this yourself in DevOps pipeline as an example. Stateful applications. This is the big one, right? Should you be doing stateful workloads in general inside Kubernetes? This one's a pretty hot topic in general, but let's say you do choose to do so. Doing an in-place upgrade is probably your best path because a lot of the unique IDs associated to the nodes, to your workloads themselves, are tied to the actual node themselves. So if I create a new node pool, the ID changes. So it's very hard to coordinate a node pool upgrade in that sense using stable workloads because it's tied to the old one. If I get rid of it, some of those volumes may not mount accordingly unless I'm also having to micromanage that whole process itself. So that is a big consideration. It's something that you have to plan and think of and test out before you actually go and do in reality. All right, so that was the upgrade strategy and thought and process. In this particular webinar, we don't actually discuss an opinionated path for that because, again, if you add in stateful workloads into that, depending on what your stateless workloads are, network traffic, drop packets, this is actually a better conversation to have with our team, which is where we usually get engaged. So feel free to reach out to your local Azure rep and ask for a black belt. I put plug in there this time. So now we can talk about ACR, so Azure Container Registries or registries in general, and the best practices around that. So first off, container registry, right? That's just if you're using something like Artifactory or Nexus or something like that, it's essentially the equivalent. It's a place for you to store your container images in a centralized location. The idea, of course, is that I have a centralized way to distribute images across my developers, across my clusters, etc. In your environment here, I'm going to just start off with the security considerations when you're thinking about container registries, and then I'll work towards how to segregate or set them up for each environment. So much in the same way that you're probably doing like code coverage, code scanning, with like SonarQube and things like that, you probably want to do the same thing with containers. So it's not, can I just replace SonarQube with container registry scanning? They actually work together. You're doing one at like a more granular level with your code as each time you're committing it. Then you're doing at another level, taking a whole holistic picture or snapshot of all your container layers themselves. So host OS all the way up to your actual application for any known CVEs, critical vulnerabilities and things like that. So what that provides for you is, okay, if you want to push and build the image up on the registry, the tool that you choose, Aquaset, Twistlock are the sort of champions in the space right now. They will scan that image when it's building to see, oh, is there any 0-day stuff? Is there anything that I should be aware of? Or maybe I'm using an outdated image that is known or riddled with problems. It can alert, and it can alert you according to, do I want a sort of a warning, like send out an email or text message to my dev team, my sysops team, whoever, to say, hey, this image doesn't really pass. We're going to give it a yellow card. Or do you want it to be a full-on stop, do not continue building, and actually block it from being deployed in your environment altogether? So that's build time kind of scanning, and that's generally how it works. Then there's the runtime aspect of it as well. So the time delay between, let's say I've run this in my environment before, it's been a couple of weeks, a new version or a new instance of that app spins up using the same old image from a week ago. And in between that time, from when I deployed it, it was okay. We got green, it was healthy. It was there are no vulnerabilities or anything to be worried about. To now a week later, oh, in fact, there are critical things that have happened to that image, right? You actually shouldn't run and deploy, and the same kind of features apply. Do I want a soft, warning kind of alert? Do I want it to be a hard stop, etc.? It also provides other security features within the cluster, but that's not really the same as when we're talking about the container itself. It can also do things like, if you've got security policies to block elevated permissions or privilege pods and things like that, those services can also integrate with that, but that's outside of the idea of the container registry scanning pieces of it. Now, on to the segregating your container registry strategy for each environment. Essentially, the key thing is to make sure that your production environment has its own container registry, right? So this is I think that's a hard rule, right? You don't want to share that registry with any other lower environment. So the pre-prod, dev, test, they should not be using the same production container registry. So hard stop there. The reason being is that you want that production container registry to be the slimmest, so to speak. It only has gold images, only has the approved images that you want to actually roll in your environment. And you don't want the extra cruft, like maybe in a dev environment, I'm running Nginx, Alpine, and Scratch, and 15 other versions of Nginx. I only want a production vetted one in my production environment, so I don't carry too many images. Not only from that perspective, but from a scanning perspective, from a security perspective, I only want to scan a handful because I want it to be quick. I want it to be, very speedy when doing that. So very key and critical. Now, for your lower environments, again, this in theory it should be a one-to-one mapping. For every environment I have, it should be its own separate container registry as well. Again, you're trying to reduce the attack vector. You want to make sure that it's only what you expect it to be in that environment. It's much easier to maintain in that sense. You do have the operational overhead in terms of, I've got many container registries, but registries themselves are relatively simple services. So there's not a lot of overhead in terms of management. Now, when we get down to dev and test environments, that's something that you can, I think, more or less safely deploy as a very large container registry shared among multiple developers. The only thing that I would probably say in this environment is you might want to have a geo-replicated container registry strategy, because you might have developers in different countries, and you might have clusters or dev clusters in different countries as well, just like production, so that it sits as close as possible and it's more performant and you get a better experience out of the box. The last piece about this in terms of managing your registry is that in Kendall section, in terms of talking about manage identities versus service principals, we want to actually assign the clusters themselves an identity. And we want to say the cluster itself has been sort of blessed to access the right registry. So production cluster has its own unique identity just for production. It can only touch or use images from the production one. And we do this via service principals, or preferably manage identity. So if the cluster disappears and dies, that identity goes along with it automatically with managed identities. If it's a service principal model, because we created by hand, there are issues where, okay, I might have forgotten to clean that up, and someone reuses that identity. Now I have access to production container images that I probably shouldn't have shared with them. So do keep that in mind. The life cycle that matters, and we're just trying to tie it one-to-one to the cluster accordingly. So this would be the path. The other path to this is to use service principals or for container registries, an admin account, which allows you to use a username and password to access that registry. So similar to a Docker Hub user account, you got a username and password accordingly. Okay, so image scanning setup. So I did mention, for their cluster, you want to use managed identities as service principals. For actually accessing image scanning with some of these external service or providers like Twistlock or Aquasec, you should be using, or you can only use, because it's a SaaS product, the admin account, the username password approach. The service itself, once you pass these values, so the registry name and the username are actually the same value. So whatever you name your registry is, the same username, and then you can choose one of these password keys you can see on the screen here. What this does provide you is the ability to rotate the key. So if you do know somehow the key or the password has been compromised, first of all, you have two different versions you can share accordingly. One for perhaps just your Aquasec tooling, and then one for maybe an admin within your environment. If one of those keys gets compromised, you can regenerate them and it'll generate a new key. You just have to go through the process of handing out or sharing that key with whoever you need to again. From your chosen scanning tool perspective, right? All you have to do is go sign up for them. They have trial accounts for each one. And what you can do is just drop in essentially the username, password, and your registry name for container registry. In this case, they have a whole UI driven around this. If you choose Azure Container Registry, it already knows to append the acr.io suffix of Azure Container Registry to your container name. That's why you only need to put it in once. And then fill out the password accordingly. Once you've set this up from a scanning perspective, this now gives you the control or the ability to say, I want to update specific images, images with certain tag, and all the different dimension or criteria that you want in that given registry. So once that's up and running, you're good to start at least. All the different dimensions in terms of how complex that scanning is, how often we do it, how frequently, that's up to your organization to figure out. And you can reach out to your security experts to help you figure out what that may look like. Okay, as mentioned before, this is more of a summary in terms of what I mentioned in terms of segregating your ACR design. Probably should have led with that one a little bit earlier, but here it is for your reference, right? Some of the criteria, some of the high-level ideas of why you want to do this for each environments. The big one, of course, being your production environment, being as separated out from your environment as you can. Okay, manage identity Azure Container Registry access. Again, here how you would enable by hand access to your container registry. So in this case, we're adding the manage identity for the AKS cluster we provision here. The scripts automatically take care of this for you. So it knows to look up the manage identity object ID from Active Directory, and the scripts will all automatically add that to the container registry's IAM or access control configuration. But if you wanted to add something else by hand, maybe you have a VM in Azure that you also wanted access to this registry, or name your other service that has MSIs enabled, you can do this by hand. Go to the IAM panel inside your container registry, go to create roles or assign roles, and search for your given managed identity. In this case, again, it's the AKS cluster, but it could be a VM. And then you want to assign it a particular role. In the case of AKS, because all we want to do is pull in images from our container registry, not push images to it, we can assign the ACR pull role permission only, so that it can only ever download images and it can never push images up there. Same thing for any VMs in case something gets hijacked. Okay, so that's it for the ACR portion of it. I'm going to send you back over to Kendall to talk about AAD and RBAC permissions for Kubernetes. Oh, I think you're on mute, Kendall.
Thank you. Yeah, so can everyone see my screen? It should be where we just kind of left off, I think. I skip forward here. There we go. Yep. Good to go?
Good to go.
Okay, awesome. So Ray touched on this, and I think he kind of did a good job at the end there, kind of showing what it looks like visually when you have that managed identity and you want to be able to give it access to certain things, right? And so I think that brings into the conversation around Azure Active Directory, Kubernetes RBAC, Azure RBAC. I feel like even myself, someone who works in this space, as these things are mentioned, sometimes I get them confused and I'm wondering, okay, what's actually happening here? What's the process look like? And Azure AD is definitely not a simple service. And so I just kind of want to talk through a little bit around we recommend if you're using Azure Active Directory to manage identities within your organization, it totally makes sense to do the same to authenticate your user to your cluster, right? So in order for them to be able to gain access to the cluster resource at all, right, and log in, you want to probably have some Azure Active Directory authentication around that. And then on top of that, there's ways once we've integrated AKS with Azure Active Directory that we can take that a step further when it comes to things that that person has permissions to do within the cluster. And so let's just kind of walk through the workflow. So the first one really is just thinking through that Azure Active Directory integration. So essentially think about your developer. Your developer obviously goes and authenticates to Azure Active Directory and is requesting an access token in order to access a subscription or whatever it may be in this case. Then the Azure Active Directory token endpoint will actually give them the access token that they need, the developer. And then that access token is obviously used to then authenticate to something like an AKS cluster. And then data from the resource is returned to, the web application, the caller, whatever that may be. And so we recommend setting this up. It's a way to continue doing what you're already doing, especially if that user already exists in Azure Active Directory. It makes sense why you'd want them to authenticate to the cluster. And so Azure Active Directory, we recommend, integrating into your clusters. So we can take that a step further, right? Within Azure Active Directory, we have users, we have groups, and then we have role assignments, right? We have the concept of, hey, I have a user. That user is assigned contributor to a resource group. Therefore, they can provision X amount of resources. And so if you are someone who's been in Azure, or if you're someone who works a lot with Azure infrastructure, you're probably familiar with this concept, especially when it comes to just some of the baseline best practices around Azure. I think, definitely get familiar with things like management groups, resource groups, AD integration, role-based access control. Like, these are really fundamental principles that help you to secure Azure all up. And so they're important to keep in mind. So role-based access control, right? I want to provide roles, and those roles are then going to give somebody certain controls when it comes to access. That's kind of exactly what that means. So there's two kinds of RBAC we're going to demystify for you, right? The first one is Kubernetes RBAC. So really that's designed specifically to work within the cluster, right? Intra-cluster resources, think things like namespaces, think things like pods, deployments, config maps, like all of those fundamental Kubernetes objects. And then within Azure, we have Azure RBAC, which is really designed to work on those Azure resources and grant permissions at the subscription level. So if we're familiar with these two concepts, we can kind of figure out, okay, well, how do they actually marry together and why are they important? So let's talk about, I want to make sure that I do this well. When we think about AKS and when we think about the AKS cluster, there's two levels of access that someone would need in order to be able to functionally work with the cluster. The first one is access to the resource in the subscription itself, right? I've provisioned an AKS resource, so I obviously need the appropriate roles and permissions within Azure to be able to access that resource, right? So that I think that makes sense. But then once I have access to the resource, it's not really beneficial if I have no permissions to do anything in the cluster, right? Maybe I can get into the cluster and I can authenticate, but then I have zero permissions to actually view the pods, view the namespaces, deploy anything, make any changes. And so that's where the access to the Kubernetes API comes into play, right? And our traditional approach is either to go, okay, we have Azure RBAC to get access to the cluster, and then we use Kubernetes RBAC to then granularly control permissions within the cluster. But we also have a preview feature, which basically is, hey, let's take Azure RBAC and actually integrate that into AKS to remove the need to provision some of the Kubernetes RBAC components as kind of a separate step. And so that's what we're going to walk through. And I'm going to kind of just walk through that authenticating to AKS, 3 buckets that you can look at. And I don't want them to be seen as completely mutually exclusive buckets or completely and totally different from another. They're really alternatives. And a lot of the alternatives are going to have to do with what your organization chooses to use, right? And so it's not necessarily that one is 100% better than the other. 2 of them are almost identical. You just kind of offload a little bit more management, which is, I think, in general, I think Ray would agree with me, where we're trying to go with AKS, right? How can we abstract away Kubernetes as much as possible to make it a consistent hosting platform for you? And then you can really focus on, the traditional application development paradigms that you're familiar with while getting the benefits of the scale and things of that nature. And right now, AKS, we don't even really say it's a fully managed PaaS service. Like, it's really, there's still a lot from an operations perspective that you have to be familiar with. So it's definitely a shared responsibility, right? Developers and operations and infrastructure, we all have to work together in order to really make operationalizing AKS possible. And so how do we simplify that? Well, here's a couple examples. So we can authenticate all of these options, authenticating to AKS, are assuming that you're integrated with Azure Active Directory. So in this case, we have Azure Active Directory already enabled on the cluster, and then we're going to use either cluster role bindings or just general role bindings in order to give permission to specific users. Now, the key thing to remember here is that the only difference between cluster roles and cluster role bindings and roles and role bindings is the level of access, right? So one of them is cluster, and then role binding is specific to a namespace. So it's just the scope within the cluster at which you actually get those permissions. And so in this case, we have a user. That user is already added or has an Azure Kubernetes user role. Maybe they don't even have that. Maybe they have a contributor role on the subscription that's going to trickle down and give them certain permissions. But the key here is, your user needs to be in the appropriate role in order to actually access the cluster. So this person's not necessarily a member of any of those admin Active Directory groups. They just have a user role. And then within that, once they authenticate to your cluster, they're going to depend on the Kubernetes RBAC roles and role bindings to be able to take action within the cluster. So if nothing's set up, they're basically just going to be able to authenticate and then not do anything within the cluster. Once we get to the second stage, or the second option, we have like Azure AD admin groups. So what that means is you still have to have user role assignment, but then that user is actually added to a cluster admin group within Azure Active Directory. And so what that means is, hey, I have a cluster admin role in my Azure AD tenant that basically says this person can perform any action within the cluster. And then basically Azure Active Directory and AKS will actually auto-generate the cluster role binding that's needed to give you cluster admin privileges. So if we look at this screen right here, you can see we have a cluster role binding, and the cluster role binding, remember, is actually going to bind the cluster role to the specific user or user group. And so that's what the binding does. It's kind of that intermediary that establishes the relationship between the role, the cluster role itself, which in this case is called cluster admin, and then the Azure Active Directory group. So you can see here that AAD group object ID, that's what's in that parameters file that we mentioned earlier in the bicep template. So just keep in mind, we now have associated an Azure Active Directory group with the cluster admin role, and that's happening via cluster role binding. And we didn't have to do anything inside of the cluster. AKS actually did that for us. So we don't have to go deploy this specific permission. But let's say we don't want everybody to have admin access. Maybe we don't want them to all be in the admin group. We could go and apply other roles, other role bindings, or other cluster roles and cluster role bindings to define groups that have lesser scopes of permission. So now, what is this preview feature that everybody's talking about? It's called Azure Active Directory plus Azure RBAC for Kubernetes. So what does this require? So basically, it's still going to require that Azure Kubernetes user role, but it will also require that you choose or select one of 4 Kubernetes RBAC roles, or you can define a custom role. But think of this as being another built-in Azure Active Directory RBAC role that you can basically assign to a user within Azure Active Directory that will totally abstract away any need to work with Kubernetes RBAC. So all of the intra-cluster permissions will be codified in each of those particular RBAC roles, and Azure will handle the intra-cluster permissions for you. So this is kind of what it looks like, right? So we have Azure AD managing not only our authentication to the cluster itself, but our authorization and our role within the cluster and the things that we can do. So there's 4 built-in roles today. I think I have a list of them somewhere. I can make sure that I include these. Oh yeah, so it's RBAC viewer. So basically someone who can really view a lot of the resources, can't do anything within the cluster. We have an RBAC writer, an admin, and then a cluster admin. So these are just going to be different scopes, right, within a namespace or at the cluster level. And so that RBAC role will essentially handle all of the traditional Kubernetes RBAC. Hey, this user can do these specific actions like list all pods or list all namespaces, or they can't do that. And so you can actually run a cool command, which is like, who am I? And it'll actually tell you like, can I, or I think you just say like, can I, view namespaces, but you put like kubectl get namespaces, and it'll literally say like, no, you can't do that. Like you don't have that permission, which I think is actually kind of cool. So it looks like this. I'm a developer. I come in, I authenticate with Azure Active Directory. Through that authentication process, I get access to my cluster. And then from that perspective, if I have a Kubernetes, an Azure RBAC role assigned, then Azure will handle the authorization of what I can do in the cluster. And if I don't, we fall back to the traditional Kubernetes RBAC, which is set up through those role bindings. So secure and streamlined, let's go ahead and extend the Azure Active Directory integration. We can offload the management of the cluster role binding, YAML, all of that good stuff. Like, let's just try to keep that administrator's overhead, lower. It also goes really well hand in hand with pod identity, right? If we can just take this to the next level, have it managed for us. We don't have to set up that manual process. We can give cluster access when it makes sense, to admins, to support engineers, but then we can also really logically isolate the actions that can happen within a cluster. And think about that, right? When we combine node pools, and on top of that, we combine some policy, we combine Azure RBAC, we really have a scenario where a developer can only access their subset of node pools and their subset of namespaces within that node pool. And so you're really doing a great job of getting further and further isolated within your cluster to keep that security and that attack surface, as small as possible. Security high, attack surface low. A couple other quick considerations here before we go into networking. Obviously, if we're trying to set up a demo or a sandbox environment and every user needs to have the perfect roles and permissions, it's not super ideal. We're most likely not going through the Azure DevOps or GitHub deployment actions in order to spin up a demo for maybe an internal call. And so you don't want to be so restrictive that your developers can't do anything that they need to do when they're playing around and trying out new features. So keep that in mind, right? The extent to which you want to implement on those lower level environments. That final bucket, the actual Azure RBAC for K8's authorization, is in preview. So obviously you can integrate your cluster. You can set up that admin group, which we actually have done in the scripts, but we're not using that new preview for authorization specifically because, I don't even think in Terraform you might be able to do that yet. I'm not sure, Ray. You might be able to speak to that. I don't know if they have that feature available.
No, I don't believe that feature is turned on just yet. No.
Okay. So yeah, that's an example, right, of something to keep in mind when it comes to those provisioning steps. And then, also another thing you have to think about is if you don't use that, that integration with Kubernetes RBAC or Azure RBAC, just think about how are you going to have your initial admin authenticate to the cluster, because they're going to obviously have to set up the cluster roles and cluster role bindings. And maybe you do that via CI/CD. So, maybe you only give your CI/CD pipeline access to do that. But just keep in mind, right, somebody's going to have to authenticate to the cluster in some way in order to be able to set up the other people's access. And so it's something to think about. And then retrofitting RBAC just is not a fun process. And so just keep in mind, especially for your production clusters, you should be using this. It's not something that should be should I use it or does it help? It's like, no, this is pretty much fundamentally something that you should be doing. And so that's why we really wanted to recommend that on day one. So I'll pass it over to Ray. He'll cover networking, and then we don't have much left after that. A little bit on application insights and some I almost said OMS, which is like a legacy term, but some stuff about container insights and log analytics. And then we'll really just kind of summarize it up after that.
Thanks. I'm again struggling to find the right window, and there it is. So I gotta skip forward.
Perfect. Yep.
Okay, networking. So networking is usually the most complex part about setting up any kind of compute environment, right? You want to right size it. You want to make sure that it's secure. And so it really is a thought process that you have to consciously consider before deploying your Kubernetes cluster. The first two things when it comes to Kubernetes and your networking should actually be, do I want to go down the path of what's known as KubeNet or Azure CNI, or the container network, the container network interface. CNIs there are lots of different CNIs. The Azure one specifically is one that knows how to speak to the Azure control plane and handle things like IP management and how to hand out IP addresses. KubeNet operates a little bit differently. So let's talk about the differences. KubeNet is the default networking model for any Kubernetes you deploy. And what it does for you is it actually deploys an overlay network on top of whatever network environment your actual virtual machines or the actual worker nodes themselves are deployed into. The benefit of this, and the main pro, and why most organizations I think that are large enough want to go down the KubeNet path, is that it alleviates one big daunting problem: IP exhaustion. So you're probably a large enterprise. You've used your entire, private IP address space. You've used up all the 10.0. whatever, and we're out of IP addresses. And so KubeNet, this helps to alleviate the pressure of sizing a large subnet for your cluster because of that overlay network. All I have to really concentrate on is the IP addresses for each of my virtual machines, and I don't really care about the IP addresses for my actual applications, the pods themselves. So in that sense, that is the huge perk of it. On the CNI model, however, the contrast to that is that every single node gets an IP address in your network space. So if you're on like a 10.0.16 virtual network, your nodes will get an IP address in that space, as will your pods themselves, right? So your pods are directly addressable in your network. So as a result, I do actually have to consider the calculation of how big my subnet is based on how many pods I intend to deploy with my cluster. So in the first one, KubeNet, if I only plan to ever deploy 100 nodes, my subnet needs to be sized roughly around 100 IP addresses, right? Give or take, depending on upgrades and things like that. On the CNI model, you have to account for the pods as well. So if I plan on having 1,000 nodes, okay, that's 1,000 IPs, not too bad, even if I'm facing IP exhaustion. But then if I plan on deploying 30 pods, or basically 30 workloads on each of those 1,000 nodes, well, now that adds up very quickly. Now I've got 30,000 additional IPs in addition to the 1,000 nodes I have. So that's 31,000. Plus I have to calculate for any upgrade nodes that I might have. If I'm doing a single node upgrade, then that's another 31 IP addresses. If I plan on doing max surge and I plan to take 5 down at a time, multiply that by 5. So that does become an issue for a lot of organizations that want to build one big monolithic cluster and presume that it will never, ever be taken down again, like the cat coming in.
I will say the cat has made his way into plenty of things. So just for those of you watching, feel free to say hey. Coda pops in at podcast times. It's just anytime he can. So love it.
I was looking at my screen. I saw the door kind of open. I was like, yeah. Is that a ghost? And then the cat comes in.
I know. I knew he was coming in.
The other thing too with KubeNet is that you have to manage route tables, because the overlay network, how do you actually know, which IP address is on which node? You have no idea from one node to another unless you use route tables. That if a 192.168 over to like a /24 onto the next one, which node does that actually land on? It's unknown unless you actually implement route tables to move accordingly. The big perk about CNI is that if you're a feature conscious or security conscious organization, you want to be on latest and greatest, you really should think about the CNI as your best path, because all the feature releases, the updates and things like that are usually implemented first in a CNI model before it makes its way into KubeNet. So it's sort of in a reverse, right? So security features is a big one on that in that sense. Okay, let me move too fast through that. Just control the mouse. So subnet calculations. So I'm not going to drain this slide because we have docs around this, but again, this kind of shows the considerations you need to think about when calculating the size of your subnet that AKS deploys into. Now, the good thing is, especially going back to like the first or second slide that we talked about in this webinar, you should be accustomed to the idea of iterating your Kubernetes deployment. Right, new feature comes out, you want to you leverage that feature, you have to redeploy your cluster. If you also need to resize your cluster, this is something you probably want to start small, right? Size it. Don't try to build for the maximum potential size of your cluster, because those IPs might not be even used. Build out a cluster as you go along, or more likely your strategy will be to have multiple clusters in your environment over time, right? So you're going to add more and more clusters into your environment, and then now we get into the idea of multi-cluster management with things like Azure Arc for Kubernetes as an example, right? So this is something that you should be considering. Network policy with Calico. So by default, or I'm going to say, I think Kendall and I are on the same page. By default, you probably should go with Calico as your network policy. And also the other opinion that we strongly feel you should do is turn on network policies. You don't have to use them right away. Make sure it's running in your environment. The default behavior, even when you do have network policies in place, is that every namespace can talk to each other. The moment you add rules is when policies actually come into effect. So what we want to do is, again, turn on Calico, make sure it's there. If you're not using it, that's fine. But it's something you can't bake in after the fact. You have to have the policies there when you create your cluster. And you could do some pretty good things with them, right? The question comes into play later on when you're playing with policies and you're introducing something like service meshes. Where do you actually put the policy and rules in there? How granular do you want? That's a little bit up for debate. Anything that gets super granular should be in the service mesh, and like general sort of coarse grain rules or guardrails around your namespaces should probably be done at a network policy level. So maybe I have an accounting team network policy, and I have a sales team network policy. At least you have a guardrail around that so they can't crosstalk to each other. Okay. So enable network policy, use it later. You don't have to worry about it. At least it's there in day one. Observability and container insights considerations. For AKS, the easy thing to toggle on Azure Monitor so I can collect logs and analytics and things like that. It's very simple. In the templates themselves, you'll see these areas for add-on profiles for each of your clusters to enable what we call the OMS agent. It's the same thing. Azure Monitor, OMS agent, log analytics agent goes by a bunch of different names. We're kind of inconsistent in that sense, but you'll keep an eye out for it. The idea is that it'll install the agent on every single node, and then any logs that your pods create, your controllers, the whole Kubernetes logs themselves, those agents will capture on your behalf and store in Azure Monitor, right? So that's done by for you out of the box. If you forget to turn it on, or you didn't turn it on originally, you can enable this, and the easiest path to that is inside the Azure portal. You can go into your cluster, go to settings, go into monitoring, go to insights, and then you can enable Azure Monitor. It'll deploy on your behalf, and then you can choose which given workspace you actually want to save that data to. Okay, so set it, forget it. There are the features with Azure Monitor as well in terms of being able to send metrics. So there's logs, so there's static logs in terms of like what's going on with your system, but there are things with metrics in terms of how many requests per second am I getting around my actual application? What's the latency regarding it? And there may be custom things around CPU and memory that I want to monitor or watch for as well. Those are metrics that I can collect. And so Azure Monitor for containers also does provide a way for you to scrape Prometheus endpoints and then visualize those metrics and also generate alerts around them. So I want to send an alert to my sysadmins that CPU workload is in 90% for the last 5 hours, or whatever that might be. I can get alerted on that and action accordingly. Excuse me. I can also send those metrics out and trigger additional resources in Azure, maybe another VM skill set or another VM living in a different subnet or even a different network altogether in my subscription to scale that up and down accordingly based on those custom metrics. Okay. For the sake of time, excuse me. What I can do with this out of the box, I can, again, set it, forget it, and not have to worry, manage, and maintain that. You could spin up your own Prometheus cluster and Grafana to visualize, but this is something at least you start collecting from day one instead of having to create all the bootstrapping and maintaining that cluster by hand from day one. So
yeah, I would say, Ray, too, like one thing to call out, or just like a couple of things, because obviously there's so many things we can say about a lot of these topics, but one thing to keep in mind is the cost of that can be expensive, especially if you've turned on all of your the logs coming from your control plane. So we see some customers who are like, oh, great, I can go in and just like enable control plane logs. there's going to be so many logs. You're going to be inundated with logs. If you do that, and it's expensive to store those all, right? So you might want to think about, what's your retention policy, offloading some of that to something like a cold storage, and also being selective in terms of like what logs and metrics you really need coming from the control plane, like what's actually of value to you. And so we've thought about, and we'll talk about this in a second, we've thought about hosting an AKS office hour specifically on the topic around like more granular logs, metrics, like what should we really be looking at and caring about. So just like keep that in mind. There are obviously nuances to some of these things, but we can't get into all of them today. But those are two things definitely wanted to call out.
Yeah, great. This slide in particular is just showing at a high level what is actually being provisioned. Again, the public Kubernetes cluster, the node pools themselves, the subnet values, as well as Azure Monitor and Azure Container Registry. So this gives you a snapshot of what the actual resources are. It is missing, however, the manage identity components, which get automatically generated. It's hard to visualize that in terms of this kind of a high-level diagram. I was going to move on quickly for the sake of time, because the review of the cluster itself is going to be documented on our GitHub repository anyways. But Kendall, I guess this is the wrap-up section for you. I can slide through these.
Yeah, sure. So, you may be asking yourself a few questions about our setup, right? Things like, how secure is this? Like, is this sufficient enough for me? Is a public cluster the way to go? We have a lot of customers who now have said, oh, private cluster, perfect. We want it to be as private as possible. Well, that comes with other ramifications. How private do you really need? Let's talk about that. Let's have a conversation. But how can we lock this down a little bit more? How can we think about things like gatekeeper, Azure policy to maybe even make this a bit more secure on top of some of these other things we've talked about? And then how do we meet some of these other requirements that may be popping up, especially from a compliance perspective? So we're going to talk through a lot of that on our next session on the 21st. Hopefully you're seeing this video before then. If not, please jump to the next recording because the session's amazing. I've heard it's going to be amazing. And then, after that, we'll talk a little bit about workloads really and making use of our Kubernetes cluster once we've kind of configured it the way that we expected. So wanted to just call out a few things. One of them is the AKS office hours. If you're on this channel, most likely you're seeing those in another channel below. But essentially Ray, myself, and some of our teammates, Dave Strabel being one of them, he wrote a book. If you're interested in learning about Kubernetes, had to throw that in there. We host the office hours every other Thursday at 11 CST, and we cover a lot of the topics that are covered here today and that will be covered in future sessions. So we talk a lot about AKS updates. We go through the latest release notes. We talk about ecosystem updates or projects that are relevant or related to the Kubernetes ecosystem. And then we typically have opportunities to ask questions and collect feedback. And then we also have the AKS product group coming on bi-monthly to cover kind of what their expectations are for the future, what they're planning to invest in. And so you can ask them about roadmap and things of that nature. And then last but not least, just a quick overview of some resources that will be linked below in the video. But also, I believe Matt will do a great job of disseminating these to people who are able to join the live sessions. So we really appreciate it. Thanks for joining and hope to see you again next time.
Bye. Thanks.
Bye.